Welcome to this explainer. Today, we're tackling a massive headache that honestly pretty much every cloud, database, or IT ops pro runs into eventually. We're talking about extracting logs and scripts from managed cloud databases. You see, when you're dealing with a fully managed environment, you get incredible automation, but you usually sacrifice host-level access to get it. Well, today, we're going to learn exactly how to bridge that gap using OCI file storage, giving you back the control and visibility you need without losing any of the benefits of your managed database. Here's how we're going to break it down. First, the host access challenge. Then we'll introduce OCI file storage, walk through the network and storage setup, attach our autonomous database, and finally, mount the compute host. All right, let's jump right in.
Part 1, the host access challenge, or as I like to call it, identifying the bottleneck. We're starting with a very real pain point you've absolutely felt if you work with fully automated cloud deployments.
So, here's the scenario. You've got these homebrew SQL or PLSQL monitoring scripts, right? Your team has relied on them for literally years. You need to run them, collect the logs, and maybe feed them into OCI logging analytics for correlation. But your managed service flat out denies you host-level access. You can't just SSH in and grab what you need. So, how on earth do you get your data out?
It's the classic trade-off. On one side, you have Oracle Autonomous Database, or ADB. It's fully automated, it's got that brilliant machine learning-driven tuning, but it is locked down tight. Even on dedicated Exadata infrastructure, no OS access for you. Then, on the other side, you've got your OCI compute instance. Full root control, do whatever you want, but it's completely isolated from the database environment. We've somehow got to make these two islands talk.
Which brings us to part 2, introducing OCI file storage and building the bridge between them. To bridge that gap, we need a shared workspace. And that's where the OCI File Storage Service, or FSS, steps in as the hero of our architecture. Now, this isn't just some basic virtual drive. We're talking about a highly scalable, fully managed elastic file system that scales up to, get this, 8 exabytes. Plus, it supports NFS, v3, and the Network Lock Manager protocol. Those robust locking mechanisms mean it's the perfect, highly reliable central hub for multiple concurrent connections.
Now, you might be thinking, why not just dump these logs into object storage? Well, sure, ADB can interact with object storage, but FSS gives us the absolute holy grail, real-time access. Instead of waiting around for delayed batch uploads or constantly polling an API, your compute instance can read those log files the precise millisecond your database writes them. It is exactly the real-time interaction we desperately need for live monitoring.
Moving on to Part 3, network and storage setup. This is all about avoiding the traps. Before we connect anything, we have to lay down the network plumbing. And pay super close attention here because honestly, this is where almost everyone messes up. You absolutely must configure these exact stateful ingress and egress ports. If you don't punch these specific holes in your virtual cloud network, your cross-mount just won't communicate. For TCP, you need ports 111, 2048, 2049, and 2050 open both ways. For UDP, 111 and 2048 for ingress, and just 111 for egress. Seriously, do not skip this. We've all felt the soul-crushing pain of staring at a connection timeout for 3 hours only to realize, oops, I forgot a single UDP port. Save yourself the misery. Okay, once your network security rules are bulletproof, head over to the OCI console. Under Storage, you'll provision your capacity-on-demand file system. Next, you configure the mount target. That's the actual network endpoint both resources will talk to. And finally, grab the fully qualified domain name, or FQDN, of that mount target. We're going to need that exact string of text later to tell our database where to look.
All right, Part 4, attaching the autonomous database. Time to make that first connection.
Since we don't have command line access to the ADB host, we handle this entirely through SQL using native cloud admin packages. It's actually pretty slick. First, you create an Oracle Database Directory object that points to your mount path. Then, you run a procedure within the dbms_cloud admin package, dropping in that FQDN we copied a minute ago. Boom. That securely binds the FSS mount target right to your database directory.
But you know the golden rule of IT, trust, but verify. Always check your work right away. Just use the UTL_file package to drop a quick text file into the root or a subdirectory of your new mount. If that PLSQL procedure completes and writes the file, congratulations, you just successfully breached the managed host barrier and your database is actively writing to external storage.
Which brings us to our final step, Part 5, mounting the compute host and completing the circuit.
So the database is writing logs out, but we're only halfway there. Our OCI compute instance needs to reach in and read them. And right here is the absolute biggest gotcha of this entire operation. The user ID and group ID between your isolated database and your compute instance must mirror each other exactly. Your compute instance can't just use some random user to read ADB files. If ADB creates files as the Oracle user in the DBA group, your compute instance must have an Oracle user and a DBA group with the exact same numerical IDs.
To make this translation seamless, OCI file storage has this brilliant feature called squash identity. Because ADB strictly operates under the Oracle database server process, you use squash identity to force the target mount to respect those exact permissions. It basically maps incoming connections to a specific UID and GID, so when the database writes a file, it gets stamped with the right ownership, and when the compute node asks for it, access is instantly granted.
To wrap it all up, log into your compute instance, let's say you're running Oracle Linux, and explicitly create that Oracle user and DBA groups so they match the database IDs. Then, run your standard Linux mount command targeting the FSS endpoint. Finally, do a quick ls command. Just like magic, those homebrew script logs generated by your lockdown database will instantly appear right there on your compute host, completely ready for your monitoring tools to ingest.
To really sum up why this architecture is such a game changer, I absolutely love this quote from our source material. The solution complements the use cases and requirements that cannot be accomplished by an object storage integration. By building this cross-mounted bridge, you unlock continuous, real-time file sharing. You're taking two totally isolated cloud silos and turning them into one cohesive communicating system. You get the simplicity of a managed database, plus the total uncompromised flexibility of a compute host.
Now that you've got the blueprint to safely and securely bust through that managed host barrier, the potential for custom analytics, monitoring, and auditing is completely back in your hands. So I'll leave you with this. Think about your own cloud environments for a second. What powerful legacy scripts have you been leaving behind just because you thought they couldn't run in a managed database? Well, it's time to dust them off. Thanks so much for joining me for this explainer, and happy building.